Dear students, in this video, you will learn about double revolving field theory in single phase induction motor. According to double revolving field theory, the field flux or magnetic flux inside single phase induction motor, it will be divided into two parts. It will be divided into two parts. The two parts having same magnitude and opposite directions. So here the double revolving field theory, which states that the magnetic flux inside the three-phase induction motor, so which will be divided into two halves, and also the magnitude of each half is same and opposite to each other. So in case of single phase induction motor, the stator produces the alternating magnetic flux or alternating magnetic field having magnitude of pi 1m. So this is the maximum magnetic flux. So according to this theory, so this will be divided into two halves. So one half is consisting of pi 1m by 2, and also similarly second half will consisting of pi 1m by 2. So these two fluxes will be opposite each other, so opposite directions. The both these components, so both these magnetic fields will rotate in opposite directions at the synchronous speed. So the synchronous speed is ns, so which is depends on the number of poles and frequency. So it depends on the frequency and stator poles, right? The two halves we can denote in terms of forward and backward magnetic fluxes. So here pi f. So here we are considering pi f is the forward rotating flux. Pi f is forward component rotating in anti-clockwise direction, while pi by is the backward component rotating in clockwise direction. The resultant of these two components at any instant gives the instantaneous value of stator fluxes at the instant. So the two components which gives the instantaneous value of the stator flux, the summation of pi f and pi b. So here pi f and pi b, the resultant will be equal to the stator flux inside single phase induction motor. The resultant flux, so we can call it as the original stator flux. So in these figures we can see the backward flux and forward flux and also resultant flux pi m in this diagram. So in this figure we can see pi b represents backward flux, so which rotates in clockwise direction, and pi f represents forward flux, so which rotates in anti-clockwise direction. The resultant flux will be equal to 0 in this case. When the two are opposite each other, the resultant flux will be equal to 0. So once if it is comes to the 90 degrees each other, the resultant flux will be equal to pi 1m. So we can see in figure C the flux alternating positive direction and negative direction. So you can see stator flux in figure C, right? And we will also move to the next one. So next case, so here the stator flux having two components pi f and pi b. At start both the components are as shown in the figure 1a. So here in figure 1a you can see, and resultant flux in this case when two are opposite each other, the resultant flux is equal to 0. So this is nothing but the instantaneous value of the stator flux at start. So at starting condition the resultant flux will be equal to 0 in this case. After 90 degrees, so you can see in this figure B, the two components are rotated in such a way that both are pointing in the same direction. So if you rotate in 90 degrees, So this will shows both in same direction. Hence, in this case, the resultant flux is the algebraic sum of pi f and pi b. Pi f and pi b is equal to pi 1 m. So here the sum of the magnitude of the two components, so that is equal to pi r. So pi r, if you add pi r, if you add both the fluxes pi b and pi f, so we will get pi r. So pi r is equal to pi 1 m. So here the instantaneous value of the stator flux at 90 degrees as shown in the figure C. So figure C, you can see the alternating stator flux, so which is having two halves. One is positive half cycle and the other one is negative half cycle. The resultant of the stator flux is equal to 90 degrees. Okay. So here we can also conclude like the rotating of the fluxes. The once motor rotates, the motor will get motor will produce the fluxes, so which will cut the rotor conductors. So due to cutting of the flux, EMF will induces according to the Faraday's laws of electromagnetic induction principle. Whenever conductor cut the magnetic flux, EMF will induce. According to that, so inside the single phase induction motor, EMF will also produce, right? So this EMF will produce in rotor conductors. So due to induced EMF in the rotor conductors, so current will be circulate, that is called rotor current. So the rotor current produce the rotor flux, again rotor current will produce the rotor fluxes. So this flux interacts with the forward component of pi f to produce the torque in a one particular direction, says that anti-clockwise direction. So pi f will produce in the anti-clockwise direction. Similarly, one more flux we have, that is called backward flux. So backward component pi b is produce the torque in the anti-clockwise direction. So anti-clockwise direction torque and clockwise direction torque. So if we consider, so anti-clockwise direction torque is in the positive direction, and clockwise direction torque will produce in the negative direction. So here we have a two equal and opposite uh, torques. So due to equal and opposite torques, so motor starts rotates. So motor starts in rotates under its own directions, right? So it will rotates in um, its own directions. So in this case, when pi r when pi f and pi b, so summation of this is equal to pi r. So pi r is pi f plus pi b. So here the resultant net torque, so the resultant net torque will be equal to 0. So since pi f and pi b is both are equal and opposite each other, the resultant torque will be equal to 0. That is net torque inside the single phase induction motor is equal to 0. And hence single phase induction motors are not self-starting. So why it is not self-starting is the resultant torque inside the induction motor, single phase induction motor is 0. That's what single phase induction motors are not self-starting. So that's what so for single phase induction motors we are using capacitors for starting, for running purposes. So those things we will discuss in further videos, capacitor start and capacitor run motors. So we will discuss in the next videos. Thank you everyone.